Said before that our last chapter is chapter 8, and the main objective of it is to solve linear system of ODEs of the form x prime equal ax. Our aim was to solve homogeneous only, plus when A is an n by n matrix with constant coefficient. We said that we will apply to it the eigenvalue. Now, for the eigenvalues, we consider three different cases. The first case when we have distinct real eigenvalues. In this case, each of these distinct real eigenvalues, it will have only one independent eigenvector, and we will have an independent solution. So this is like the trivial case that we have. Then we discussed the repeated real eigenvalues, and this repeated real eigenvalues, we also make it as two subcases. The first subcase is when it's repetitive, but it has two independent eigenvectors, and in this case, we don't have any issue for it. We will have two independent solutions. The second case is when it has multiplicity 2, but it has only one independent eigenvector. So we will get only one solution, and the second solution, it will be of this form. If you look at the second solution, basically we don't have problem in it, except P, we don't know it's what. So this P, we will use K to find it. In which manner? A minus lambda I. Instead of putting Q0 to get here, we would put K and get. This time, if it has multiplicity 2 and it has only one independent eigenvector. Now, what if it is multiplicity 2 and it has multiplicity 3 and it has only one independent eigenvector? So we will have x2, we'll find it the same as the first one, and we need also x3, because again, we have three independent solutions, we need to find the third one. So we will have P. Now, K and P, we know how to find them. We need Q, which is A minus lambda I, and here we will put P in order to find Q. Now, in generalness, what if I have multiplicity 4 and one independent eigenvector? So these are the way that we find x1, x2, x3, x4. Okay, so this is the general case just for you. But will I bring for you an eigenvalue that is repetitive 100 and ask you to find them? Of course not. But just like for you, from where did we get the over 2, or why do we have over 2? Because of this formula. Okay, now how did we get this formula? Because we have one solution, we need another solution that is independent. So we use the Wronskian and we try to get a second solution from it, an elevation between them, and so on. Now, what's left? We're left only with complex eigenvalues. What do we mean by complex number first? Okay. We have imaginary. So we'll start now with the complex eigenvalue. It means that we have alpha plus I alpha, like 1 plus 3i, 2 minus I. Now, when we say V bar or the conjugate, it means that the plus we make it as minus. And what's the idea of the complex number? The idea of the complex number is I squared is equal to -1. Now, why do we call it complex number? Because in our real space, the equation x squared equal -1 is doesn't have a solution. So we created a space that is larger than our space in a way that the equation x squared equal -1, it has a solution, and this solution we talked about imaginary. Why do we call it imaginary? Because our real space doesn't have a solution. So we imagine a space, a bigger space that can have a solution for it. Because of that, we denoted it as I, not we now one side to go there. Okay. Okay. Now, if we have complex eigenvalues, they are numbers, normal numbers, but they are complex. So logically, when we are finding eigenvectors, what should we get the eigenvectors also as? Complex. But the solution, it's not complex. The solution is real. Okay. What do you need here? If I'm solving a differential equation, I need a real solution for it. I don't need imaginary solution. You need the real solution to work with, right? Okay. So need to do first? First of all, we will find the eigenvalues. We will check, are they real or complex? Real will check if they belong to the first or second case. Complex, we will write that. Now, the good thing about the complex eigenvalues, if let's say we have an eigenvalue, its conjugate is also an eigenvalue. What do I mean by this one? It means that if I'm saying 1 plus I is an eigenvalue, it means that 1 minus I is an eigenvalue as well. Okay, conjugate. Or if I'm saying 1 minus 2i is an eigenvalue, it means that 1 plus 2i is an eigenvalue. Do I find the eigenvectors for both of that? No, we find just the lambda. So, okay, it's complex. We are scared a little bit about complex, but the work for it is much easier. Okay. Okay. Now we will find eigenvalues. We will write the eigenvalue as alpha plus I beta. And we will find its eigenvector K1. Okay. Now, what do we mean by B1? This K1 that is here. We will write it as B1 plus IB. What do you mean by it? It means that we will separate it as a real column vector plus real column vector, and we put I before it. Does it make sense? And then what will be the solution? How many solutions should we get? 2. The 2 independent solutions. So this is X1 and this is X2. Beta, we know it. Beta and alpha, we will get them from where? From beta. And B1 and B2, we will get them from here. Okay? Eigenvector, we will no, the eigenvector is the normal. We don't create a way. But the idea is that we will learn how to deal with complex numbers. When was your first, your last course? You took it at complex numbers. Calculus 2, we don't need this. I think 3 calculus. But in your engineering, I remember that my sister is signals or something.
After different.
I remember that there was a course that she took in it Fourier transform. You don't use Fourier transform. But she took in it Fourier transform. She applied it to the engineering. She did not take it as a math course. I'm not sure. But my sister is computer and communication, so she used it in one of these courses. Mm-hmm. But the complex numbers, we took it in school, right?
Yes.
What we will do today is that we'll solve an example in details. Then we will go for an A-class activity. Then I will share with you an example that you will solve at first. Hopefully today, if everything was okay, we will be able to leave the class like 15 or 20 minutes before.
Can we have a message from this and
But this one, I'm finding it just for the complex. For the real, you will find it's all one. So you will get X1, X2 for the complex, for lambda and lambda bar. And then X3, you will find it for the real. C1, X1 plus C2, X2 plus C3, X3.
And B1 and B2 will be better.
Of course, because it's a solution vector. Okay, did we write these ones? Payments, we will screenshot the question and solve it together in people. This is an initial value problem. Even if we have an initial value problem, we first need to solve it, to solve the differential equation, right? What's our A here? Let's highlight our A.
Sorry.
This is our what, miss? Okay. What do we need to find, miss? Eigenvalues, I expect that all of us are able to reach the characteristic polynomial. So for eigenvalues, miss, what do we need to find first? Which matrix? A minus lambda I, which is 2 minus lambda, A minus 1, and minus 2 minus lambda. And it's again, if we put A minus lambda I or lambda I minus A, both of them are accepted. Now, for the eigenvalues, what do we need? Determinant. Okay. How do we find determinant of 2 by 2 matrix?
Minus.
Main diagonal minus the second diagonal. So please find it and give me the characteristic polynomial. Minus 2. So what will we get here? Main diagonal 2 minus lambda into negative 2 negative lambda minus 1 into A equal to 0. So this one will get lambda squared plus 4 equal to 0. This one is the characteristic polynomial, and I expect that all of us are able to do this one, right? Now, this one, the solution of it, basically it doesn't need calculator, but if you did it using the calculator, it's fine. We will get lambda equal plus or minus 2i. It means that we got lambda equal 2i and lambda equal negative 2i. Is it necessary to work with both of them? One of them. Choose any of them. Suppose that I chose the positive because I'm a positive person. It's okay. Suppose that I'm keeping that I wanted the negative. Also, our two answers will be these. But choose one of them. So lambda equal to I. How can we write it as if we have 0 plus 2i? So alpha is 0 and beta is equal to 2. This one we will keep it now in a box and later we will go back to why this? Because what do we need here in the solution? We need our alpha and we need the beta. So I need to identify what's our alpha and what's our beta. At this moment, we don't want to replace. At this moment, we need to think about some of the eigenvalues. The next step is the eigenvalues. And which lambda we will choose? Either 2i or negative 2i. We don't choose both of them in the case of complex.
So there's this one in
Yes. So once I will give you time to do it, miss, to think about it, and then we will discuss. So I will place it in this is 2 negative lambda, this is negative 1, this is negative 2 negative lambda, and this is 8 or negative 8. So substitute lambda equal to I and check, try to solve it. Hopefully, starting from next year, we will, in linear algebra, we will include the complex part of eigenvalues and eigenvectors. Yes.
This is, I mean.
It's not included in our syllabus. But for the new cohort that they will take the course, they will take them also as complex. It's the same. There's nothing new that they are learning, just like they are dealing with complex instead of real. Okay, let's substitute. 2 minus 2i, 8, negative 1, negative 2, negative 2i, and here 0. Did all of us get this one? Okay. The shape of the matrix, we transform it in a way that is easier for us to deal with. If I have complex and I have number, I prefer to see the number one up. So I will switch them. Okay, I will put it in this way. 1, 2 plus 2i, 0. Why did I put 1? I don't like to see the negative 1. I multiplied by negative 1. And this one is, I will put it as 1 minus I 4. So what I did exactly is that this one, I divided by what? Half. This one I multiplied it by half, and this one I multiplied it by negative. And then what did I do? Interchange between them. Is it necessary? Solve it in the way that you feel more comfortable. But for me, I prefer to solve it in this way. Okay, now this one, what should we have before it, below it?
We must have a minus 1 plus.
So we need to transform this 1 minus I to 0. We should use the leading entry in row 1. Can we try it?
So multiply up by I.
Yes. Try to make the number that is below the 1 add 1 using elementary row operation. Okay, which elementary row operation? R1, we will add it to R2 in a way that we will get 0 below 1. So we should multiply by the negative of this one, okay? The first row is the changeless.
Yeah.
So 1, 2 plus 2i, 0. This one for sure it will be 0, right? Now, this one we need to find it. It should be 0 for our answer to be correct, but we will find it together. So minus 1 minus I times 2 plus 2i. So we will have minus 1 minus I plus 2i. And we will add it to 4, right? So plus. This is equal to what? Minus, I will keep it here. We have here plus 4 and 1 times 2, 1 times 2i, so we will get 2 plus 2i. That minus I times 2, minus I times 2i, minus 2i square. Multiplying this, is it okay for us? Multiplying complex numbers as if we are multiplying polynomials. So if we look at 2i and negative 2i, they are cancelled together. Now, Miss I square, what did we say about it? It's equal to 1 minus 1. So what did we get here? 2 minus 2 into minus 1 plus 4. 2 minus minus 2, 4. Minus 4, if we have a minus here, minus 4 plus 4, it's 1, 0. So here, what should I put? And it's expected to have the 0. We are not.
Constants we use x.
He wants to do. Did we reach the row echelon formulas? What's the next step? We need to continue solving it. It means that we need to find the eigenvalue. We have questions before we proceed, Miss. So if you look here, we are not creating something new. We are using again just eigenvalues and eigenvalues. But instead of having real numbers, we are having complex numbers. Okay, which variable doesn't have leading entry? The second one, name it whatever you want. I will name it as K2. You want to name it as R2, Z2, or whatever, name it as you prefer. So this one, K1, and this one, K2. So K2, what should we say beside it? P and the C belongs to R star. Is it clear? Yes. Let's see what will happen. K1 plus 2IT equal to C. Means that K1 is equal. Negative. Can I write this one?
Next slide.
Minus 2 plus 2it and here t. Can we take t in common list? Can we take t in common?
Yes.
Okay, we got this.
We can find the numbers.
Because we need B1 and B2 now. Both of them, they should be numbers. But B1 is the real and B2 is the imaginary. We put I before it. Okay, so let's go back and summarize. Lambda equal to I. It goes to 1 plus minus 2i, and here 1. Is this one, can I write it as 1 plus 0i? Can we write it in this way? Now, I need from you to do, what I need from you to do is to separate this one as real and complex. What's the real of this part? Minus 2, 1. And the imaginary? Minus 2, 0. The I did not need it. I put it outside. Okay? Now, miss, this one is what? B1. And this one is B2. So alpha is equal to 0, beta is equal to B1 is this one, and B2 is this one. Is there anything else that we have to do, miss, or we have to find? We found everything. What do we need now to do as a lambda? Substitute to get x1 and x. Let's go back again and talk about the stats that we did. So we said that in case we have complex eigenvalues, we should write lambda as alpha plus I beta. And at the end, our solution, it will be of this. Alpha and beta, we will get them from the lambdas. Then we need B1 and B2. We will find it from the eigenvector. So what we did here is that first we started finding the eigenvalues. We got this one as our characteristic polynomial. So lambda is equal plus or minus to 1. So alpha in our case is 0 and beta is 2. Alpha is the real, beta is the imaginary. Okay, then we found the eigenvectors. The eigenvectors, when we found it, we separated it as real and imaginary. So this is B1 and this is B2. What's the next step, miss? We need to substitute where? We need to substitute. So we need to substitute here. Okay, let's substitute x1 equal e power 0 t. Why 0 t? Because alpha is 0. And what's e power 0, miss?
1.
E power 0, this one is 1. Okay, we have b1 cosine, what's vector, miss? Okay, minus b2, and here what do we have? Sine. This one is x. What was b1? Minus 2, 1, and b2? Minus 2, 0. Done with x. Keep it in this way. If you want to simplify it, but write it as one factor, I don't mind. You can write it as minus 2 cosine t minus 2 sine t, and here cosine 2t. Only, yeah, we can write it.
Okay. Do you need to add the I as well? Or?
No,
No.
it should be real,
Okay.
of course. Now, x2 is equal to what?
Minus
Again, e power 0 t here, and again, it's 1. We will get here cosine 2t plus something sine 2t. And here we will put v2 instead, and here we will put v1. Okay, is this our final answer, miss? No, we found two independent solutions. What do we need to write now? The general solution. Exactly. So our final answer, I will go back to the slide. Our final answer, it will be x equals c1x1 plus c2x. Do we have questions now? Now, can we simplify it more to look better? For me, in the exam, if you have such a question, first of all, reach this one and write c1x1 plus c2x2. Now, after you finish all the questions, if you have time, we can simplify more x1 by writing it as one factor.
Okay.
Exactly.
Yeah.
Now it's better to write it, but keep it till the end. Do we have any questions, by the way? We did not finish the question because the question was about initial volume problem. So still, when we reach this one, what do we need to find? C1 and C2. So we substitute t equals 0 and check, we will get C1 and C2 as well. We solved like this example, finding initial volume problems, so I will skip it a little bit. During this time, we'll prepare our activity and then we'll solve an example on this one to make sure that everything is clear. Do we have any questions, Liz? Is it difficult? Is it difficult, Liz? Okay, so we have any questions so far? Is in the QR code? Did all of us join us? Can you start? Mohanna, did we join? Laplace of ut minus 9. Discuss the class lectures. The unit step function, we said that Laplace of ut minus a is e negative as over s. And a here is 9, so we will get e negative 9s over s. Those who put the e negative 9s, didn't we attend last lecture, miss? Laplace of t minus 3, ut minus 3, which is Laplace of f of t minus a, ut minus a. If you still remember, the Laplace of it is e negative as, f of s. And what's a here? A is 3, and f of t minus 3 is t minus 3, so f of t is t. What's Laplace of f of t? It's 1 over s squared. So we cannot have it as over s cubed. We should have something in t squared to have it s cubed down, right? Exactly. I think we still have only these two questions. Here x prime equal ax. 0 is an eigenvalue with corresponding eigenvector 1, 1. What will be a solution for x prime equal ax? Be a solution vector x, right? So the first entry will call it x, and the second entry will call it as y. So here we have e power 0t. What's e power 0t? 1, right? And multiplied by the eigenvector 1, 1. Is to be e power t. We should have lambda equal 1 as an eigenvalue to have e power t. But here we have lambda equal 0. How will we get the e power t? Okay, this is our last question. Here we are saying 1, 1 ET and 1, 2 E2 ET are solutions. We need to check if they are dependent, independent, and why. You can solve it. So from the first one, we will get ET, ET, and from the second one, ET, 2 ET. So what's the Ranskin of it? 1 times E power T. So is it dependent or independent? Independent, because E power T is not equal to 0. Okay. Those who put it that they are dependent, did you understand it now? Is to be dependent, even if they have the same E power T, we are okay with that if the vectors are independent. The vectors here are independent, not scalar multiple of each other. Who's W? Sure. Now regarding these questions that we shared, I hope that you took some notes about them. And if you face problems like solving them, you will go again through the material. By the way, today's lecture is recorded. Monday's lecture, it will not be recorded. Okay, now to make sure that everything is okay regarding what we explained, here we have a question. Okay, if you don't want to look at the screen because it's not clear enough, I already shared with you the file on Teams. We need to solve exercise number 14. So what we need to do is we need to solve it. I need you to solve this question. Find we call AX. So first we need to find the characteristic equation, eigenvalues, eigenvectors, and eigenfunction. Please start. We can do it each two together. Please go to the notes in order to be able to solve this one. During this time, I will take at them. Please, once you reach the characteristic polynomial, please raise your hand to share. What did we get? Okay, perfect. So to just find out the eigenvalues, we should get complex eigenvalues. When you find the complex eigenvalues, also let me know. 2 plus, yes, all of us should get the same answer as this one. So please, all of you make sure that you got this one. And when you get lambda, I'm waiting the lambda from Ahmed found it. I will find the other. I will check with the other ones. Khaled is not here. Muad is not here. Dr.Madeleine is here. Hamad is not here. Abdullah al-Hajimi, Saif is here. And where's Mohsen? Mohsen is not here. Talal here. Rashid is not here. Nasser is not here. Ali is here. Muhannad here. Ishaq is not here. Basil is here. Hamdi is here. Abdelaziz Mahmoud is here. Shahid is not here. Chireneyo here. Abdel Ghani?
Yes.
Harun is not here. Amir is not here. We can solve at each two together, especially for those who came late. Mona is here, Real is here, Tala is not here, Fatima Sharabat, she's not here, Mariam is not here, Huda is not here, that is here, Halima is not here, what Habib Tahrim here, Noor is not here, Sama she's not here, Asma as well. Aurad is here, Mira is not here, Basma, Maya, they are not here. Rahma is here and Fatima is not here. Did we get lambda asmas? 2 plus or minus 2i. So this one is what? Alpha. And this one that is here is what? Beta. Did all of us get this one list? Try now to find the eigenvectors. Let's take around 5 minutes to find the eigenvectors, and then we will discuss them on the board. We cannot find C1 and C2 here because it's not the initial value problem. If we want to find C1, C2, like already we get a real solution, so just complicating. Okay, let's see. Let's just to make sure all of us were able to reach the characteristic polynomial, which is part E, and find the eigenvalues as D, which is D, sorry, which is D, and find the eigenvalues as 2 plus or minus 2i. So now, what do we need to do? We need to substitute, right? What was A? 2. So 2 minus, okay, and here what do we have?
Minus 2.
And here? 2, and here?
2 minus.
What's our lambda list? 2 plus 2i. Why did I choose the 2 plus 2i and not 2 minus 2i? It's optional. Choose any of them. Okay, miss? So I copied it correctly, miss. What will be now the new one? 2 minus 2 minus 2i minus 2i minus 2, 0, here 2, and here minus 2i, and here 0. Look, all of them are multiple of 2. I will divide. What we will do here is half R1 and half R2. And then I will interchange. Why do I interchange? Because I prefer not to see the complex number up. I prefer to see a number, a normal number up. Okay, miss? What would we get now? 1, negative I, negative I, negative 1, and here what? 0. Now, this is our leading entry. Below it, what should we have? 0. Try to make it as 0 now.
We know we can, with that equal, we just cancel one without making it 0.
In this case, of course, they are multiple of each other.
So can just cancel.
Yes, but what if I have 3 by 3? You will not know which one is a multiple of other, or none of them is a multiple of other. Maybe the third is a linear combination of the first 2. So I'm teaching you it in detail just to teach you how to multiply and add when we have complex numbers. But logically, in the exam, you mean, of course, the last row should be. In the case of 2 by 2, yeah, you can cancel. But 3 by 3, you cannot do it. You have to work it. Okay, so to make the minus I as 0, we should I R1 plus R2 gives R2. Do we agree, miss? Write the new matrix. What would be the new matrix, miss?
1 minus 5, 0, 0, 0.
Oh, what will be the new matrix? The first row is the change. 1, negative I, 0. This one for sure is 0. Now this one that is here.
0, 0, 0.
It is negative I square, negative 1. And I square is what? So minus 1, minus 1, minus 1, it's 1 minus 1, which is what? 0. Continue it, miss. Now continue and find K and substitute in the formula. Find the eigenvector, miss, and substitute in the formula. Miss, for the annotation, we have the previous cases as a file, and we will have the complex case also as another file. Okay, now, let's go back again to this was our solution, right? Okay. Now, what will be K1? K1 minus IT equal to 0. Why? Because we put K2 equal T belongs to what, miss? So what will be K1 in our case? I. So what will be K? IT, and here what do we have? T, which is T, I1. Okay, miss? What are we saying here? Lambda equals 2 plus 2i, it goes to I1. Separate this one as B1 plus IB. Separate it. Can I write it as 0, 1? Can you write it in this formula? So this one, 0 plus I, and this one, 1 plus 0, 1. So it's 0, 1 and 1, 0. So what's our B1?
0.
This is what, miss? The blue one is B1 and the gray one is B2. Are we done? And you want me to substitute alone in the formula, miss? So we need to substitute now in the formula, right? To get x1 and x2. Okay. So this one is B1 and this one is B2. What do we need as the last step? Where should we substitute? In this formula. Substitute in this formula and then write x as C1 x1 plus C2 x2. So we have alpha, which is 2. We have beta, which is 2 as well. And we have B1 and B2. Substitute this. Instead of alpha, miss, what would we put here? 2. Right? Instead of beta, was Ahmed. Lambda it was 2 plus 2r. So alpha is 2 and beta is 2. B1 is,
0,
we will put here 0, 1 and B2 1, 0. And here we will put B2 1, 0 and here B1 0, 1. And we are done. Is it clear, miss? Just to tell you, how can we write the answer as in a simpler form, like we can add them at the end. Not much. Okay, no, here also they did not add one.
Yeah.
I prefer that we add them.
they add both.
Any questions? Can we try this one now? So the first step always we find the eigenvalues. After the eigenvalues, we need to check which case these eigenvalues they belong to, whether it is real or complex, and if it's real, if it's repetitive, or that. Yes, -2 with multiplication. So, did all of us reach the characteristic equation as lambda squared plus 4 lambda plus 4 equals 0? So here, how many eigenvalues do we have? We have 2, but but this one, it has a multiplicity one, 2. So lambda is equal -2. It occurs how many times? Twice. What's the next step? What do we need to find for it? Eigenvectors. If it has 2 independent eigenvectors, it's okay for us. We are almost done. If not, we need to find. It has one. So we need to find P.
-2.
The eigenvalue is -2 and it occurs twice here. We got all of lambda squared plus 4 lambda equal to 0. But lambda equal -2. What's the multiplicity?
2.
Multiplicity 2. So now what do we need to do? We need to find eigenvectors. -1, this is 1. And this one is -3 minus 2, we get -1. And -1
1.
plus 2, we will get 1. We will transform it into what? Row echelon. This statement, did all of us make it? Have we noticed that these two rows are multiple of each other? So are we left with? We can keep one of them, right? So we can say R1 plus R2. Now, what can we say here? This is K1 and this is K2. Say that this one goes to N R star.
So 0, 0 to the answer.
K.
-1.
The K that you got. What will we get here? K1 plus P equals, so K1 is equal to what? Get it? These steps, all of us did it, miss? Now what do we get, miss? Negative TT, which is T into -1, 1. So what we got here is lambda equal -2, which has multiplicity 2. It has how many independent eigenvectors? 1. So how many solutions from this one we can get? We can get only 1 equal -1, 1. E negative 2t. What do we need to find now? X2. Can we find X2 by finding eigenvectors? Already we found all eigenvectors. We cannot find any more eigenvectors, right? So go back to the formula that we wrote last lecture and write X2, and we need to find the vector P. Tx1 plus P. What do we need to find now? This P. How do we find this P, miss? What do we put here? We put K here. And we rewrite the matrix. What was the matrix here? 1, 1. Oh, let's solve this matrix. Let's solve the segmented matrix in order to get these. So here, what do we need to put this? R1 plus R2 gives R2. Can we solve the systemness? This case, it was explained last lecture. Miss. Did all of us attend last lecture? Last lecture is it was recorded. We can go anyways through the recording, and if you have questions, let me know. Yes. what was the formula? Just, did I write the formula correctly?
The X1 plus
T times the first, right?
yeah,
Plus PT minus 2T.
that's X2. Alone, yeah. Yeah, alone.
Let me just check the formula again. Check. What's the formula? T X1 plus PE under T, as we put it. Okay, yes. What did we get the answer for this one? Did we solve it, miss? Did we solve this one, miss? What did you get it as? What did we say here? We will solve this one as P1 and this one as P2. So what will we get here? P2 equal T. It means that P1 equal 1 minus T, right? And we will take T equal to 0. So P, it will be 1, 0. We can choose T equal 0 or T equal any other value. In this case, it's easier to choose T equal 0. After that, this P will substitute it where, miss? Here, and this will be our final answer. Okay, miss? Anyways, regarding chapter 8, we have to go through the recording, through the material. The annotations, they are in 2 files. One file covers the previous cases, and the new file, it covers the last case. So we have a homework. This homework, it contains 16 MCQs, but it doesn't mean that 16 independent. Like, instead of just giving you x prime equal ax and asking you to find the answer, we divided it. Characteristic equation, eigenvalues, and then solution in this way. So it doesn't need time. It covers all the cases, the complex, it covers the distinct, and it covers also the repetitive. You have time for it.
Yeah.
You have till 1 day before the exam. So logically, you should be studying before. You cannot tell me that we have lots of things. You want to study for the exam, so you need to do the assignment. But this assignment, it just covers chapter 8.
Complex and
It's similar to the questions that they are in this sheet that we are solving now.
so it's both complex and linear.
Yeah, it covers everything because the complex is also included for the exam. Now, what we will do next lecture is that also I collected some of the questions from the book, but in the form of MCQs, just like to make it easier for us to, if we don't want to solve it in details, just to pick the answer from 6, 7, and 8, and we'll solve them hopefully next Tuesday. Okay, miss? Again, it doesn't mean that these questions are in the exam. Of course, they are not in the exam because they are MCQs. So we are just solving questions to make sure that all the ideas, we are okay with the ideas that we have. It doesn't mean that we are solving the question of the exam. Do we have questions, miss? Okay, we're done for today. Have a nice weekend. I will see you hopefully next week, except for those we are being an algebra. Yeah, I'm on flight by
Oh, you can plan to make it.
the integer I define for
So it's better we simplify it, not leave it the way.
leave it.
I can leave it.
Yeah, you can leave it and solve it. Just like to avoid, if you have negative, you may have constitution errors. So I avoid to have the negative %. She's going to be here.